altered physical characteristic. Okay, so which is worse?
Prof, what's the tree again? What's the tree?
I thought I should be asking you.
Instant death, delay, and delayed altered. Sorry.
Yeah.
Oh,
Right.
repeat again. What's the first one?
Completely destroyed, immediate death.
Immediate death. Okay, that means you go fix the chip after that. I got this last time. I didn't know. Fix everything. It didn't work. So I'm going to buy the chip and put again. That means immediate damage. Okay. Second is
Emotional damage.
early. That means the reliability is shortened. Say this chip I expect to run 10,000 hours. It failed at 3,000 hours because it was zapped by PST. Now, that is the worst case because you fix everything and then you actually interrupt the service. Okay? Right. That's not the worst. The worst is what? The last one. Characteristic altered. That means it did not function as it was supposed to function. And of course you didn't know about it until some critical thing, it may crash the aeroplane, Okay? So these are the three mode of failure caused by ESD. Okay? This is what I mentioned here. So this one we mentioned to you. Now what this is important because there may be question asked about this tribal. Why is this tribal so important? Okay? Right. It's the gap. When you are designing something, you make sure that the gap is not too high. So this is tribal is to understand how to prevent generation. Okay? So later you will talk that there are 4 principles of DSD protection. What are they? First is to prevent generation. So you have to prevent generation, you got to understand the tribal system. Okay. Say for example, you are going to a fuel tank to work. Okay. What kind of clothing do you need to wear?
Cotton.
Cotton, okay? You're not allowed to use nylon because nylon rub on the surface of the aircraft can generate static. And then you go to a fuel tank, a static blast, boom, the whole fuel tank will blow, you see? So all of us got to change our clothing too. So you have to understand this for this called prevent generation. Okay? Okay, so if for example silt and mica, I told you that then can give you a charge. Okay, so the distance details the size of the charge. So you'll try to minimize the distance when you are designing a component. Okay? Right. I was telling you that my shoes, when I walk here, I don't have a problem because probably the material of the shoe and this is probably the gap is very narrow. Okay. Now I told you one shopping center in I don't know where it's still there. Every time I roll the thing until I go to a counter, I always get an electric shock. That means my shoe and that part, or maybe the trolley, the wheel, has a very high electro tribal difference. So by the time I reach the counter, go and pay, I always get a shock. One shopping center in Love City, I remember. Giant Love City. I don't know whether it's still like that. I always get fun going there.
Is that the Bukit Timah there?
Bukit Timah here.
South City.
You gotta buy car.
Love City, yeah.
You gotta buy the horse.
I don't know whether it's still there. Last time there was a giant, just a huge giant.
The giant.
So every time I go there shopping, I'm sure get a shock one. And I love it because it's very hard to get a shock in Singapore.
You mean this one?
Because the humidity is very high.
Last time it was a
So
shopping mall.
most of the charges are
Very
distributed.
saturated.
But I don't know why that particular shock.
Sorry,
And in overseas, we get it all the time.
Stay.
Every time in the winter time, you go to the hotel, the moment you go to the door, you have to put there's a spark. You get very annoying actually.
Save the sea.
So in a cold country, you don't get a lot of stuff. So once I was in Beijing, I think. It was really cold until the humidity was really low. What happened? You go shopping, you bring all the shopping, open up, and you put the plastic bag. You know what happened? The plastic bag actually gone to the ceiling because it was electrically charged, and then they will just actually get to the ceiling. So we had a serious problem. We go and bring down all the plastic bags, goes up to the ceiling. Can you imagine? That means the charge is very, very high. So in Singapore, you don't get all these things. So once in a while you get it, you get fine. Okay, so the importance of this is to prevent generation. Okay, right. Now we need to know metal, right? Okay, now don't need to remember. You have to know these things by nature, by your scientific training. Okay, right. What is liquid? What's the fourth? There's a solid, liquid, and gas. What's the fourth state of matter?
Solid, liquid, gas.
Plasma. Okay?
Plasma.
Yeah. That means the electrons are stripped off from the ion, so it exists as the neutral state. But internally, there are positive and negative ion in a dynamic movement. Okay, that's called plasma. Okay, that's when we use all the gas discharge tube are using plasma. Chemical, you know what's an element, what's a compound? Okay, you better know what it is, right? Mixture. Of course, I won't ask you a question on this. If I ask this question, it's a gift. No, okay, you have one or two gift questions. Occasionally, okay. So, molecules, okay, atoms. This is a model of an atom. This is not the real atom. Don't forget. What model is this? Whose model is that? Bohr's atom, okay? This guy, Niels Bohr, okay?
Bohr.
So why is it called Niels Bohr? He's the one who actually postulated this. And up to today we use this. And it's so good because it explains a lot of things. Okay? We don't care whether it's real or not. Scientists don't care what is the truth. We're not interested in what is usable. Okay? Elegant solutions, so to say. So this is Niels Bohr's atom, and this is how the interaction, remember? Like electron, like proton, neutron. Okay. Now interestingly, do you realize that this hydrogen atom has a neutron? Is it normal? It's not normal, okay? Normally hydrogen do not have a neutron. Okay? So this is called heavy hydrogen. Okay? And then this is called what is the term using? Isotope. Okay? Isotope are atoms that have the same atomic number but different atomic weight. So this is an isotope of hydrogen. Okay? And what is there's two more. There's another hydrogen isotope, another two neutrons. This is called tritium. So it's called H3 tritium. This is called deuterium. What they use for? Nuclear energy. Tritium and deuterium can be used for fusion. So it's very important for future. Okay? So you should recognize that this is unusual. This is isotope is quite rare. Okay, the structure of an atom, like a hydrogen of this size, you know whether I ask you this kind of question, but I have to know about it. Okay, structure, this is a good map of what is happening. Okay, proton, neutrons, and electron. What do you think is the fourth element of all the things that are happening? Photon, don't forget. Photon is not part of matter, but it interacts with matter all the time. Okay? So don't forget this word called photon. Yeah. So a photon is the first, the what I call the smallest quantity of what? Energy. Electromagnetic energy is measured by photon. Okay? So photon is measured by this equation, E equal hf. H is Planck's constant. So the energy of a photon is dependent on the frequency. The higher the frequency, the higher the energy. So for example, blue light and red light, which one got higher energy? Between blue and red light, which one got higher energy?
Red.
Red. You? Blue?
RGB.
Red?
Maybe blue. RGB.
Which one got higher energy? Red and blue light?
Blue.
Blue.
Correct. Blue.
Must guess one, don't worry about wrong or right.
We are engineers. We write only. Later answer.
It has to be blue.
Purple lah.
Blue is higher frequency, okay? Red is the lowest energy, okay?
What?
It's okay. The quiz I remember.
Doppler effect, red
Why you, all the red shift, right? So red is lower frequency and lower energy. Blue is high. That's the reason why your LED and your laser start with the red, because it's easier to make red laser, okay? Then it goes to green, and then it goes to blue. Right? That's why this is a green laser. Right? It takes a lot of energy. The battery runs out very fast. The red one doesn't, because it's much lower energy. Okay? Go, so atomic mass number, okay? So this is what it's there. So notice that some has 4 protons. I just go through this and let you know. Carbon is the most interesting because all our whole life is made out of carbon. Okay, so we call it a carbon life. Okay. So there are 6 neutrons and 6 protons and 6 electrons, of course. And the reason why carbon is interesting is because there are 4 electrons outside. The valence shell always have how many? Actually, I switch off the microphone. It's okay, like, you're so small.
4. 2 plus 4.
The valence shell will always want to have 8.
Oh.
So if you are less than 8,
Semicon.
you will try and
Attract.
Conductor, insulator.
so why is 4 so interesting?
Semiconductor. Does not want to give or take.
Oh, it's okay, okay.
Semi-stable.
Semiconductor, you see? So most of the conductor have excess electron. Okay? Most of the insulator has deficient electrons. Semiconductor have exactly 4. Okay? So it can behave anyway. One of the characteristics of a conductor is what is the coefficient of resistance? Positive. Temperature coefficient of resistance. That means the higher the temperature, the higher the resistance. Semiconductor is the opposite. The higher the temperature, the lower the resistance. So these are properties of matter. Okay? Right. So carbon, the exciting argon, this is what I call noble gas. That means it cannot react with it will not react with anything. Okay? And notice that although it has 18 electrons, it has 22 neutrons. As atoms get bigger, you get more neutrons. This one is like a glue. See, like hydrogen don't need a neutron because there's only one. So you put 2 neutrons together, what happens? They're going to repel like crazy, right? So you need the neutrons to hold them back. So as the atoms get bigger, there are more and more neutrons. For example, uranium. How many neutrons do you think are there in uranium? Uranium is the heaviest natural atom. The atomic number is 92. The heaviest, highest. 237. 237, 235. There are many isotopes. As the thing gets bigger, there are a lot of isotopes. Okay? So certain uranium 235 is fissile. That means you can use it for atomic bomb. You can make atomic reaction. The normal one is 238. 238 is quite passive, but it's still radioactive. Okay? So each isotope behaves slightly differently. Okay? Right? So oxygen, of course, you know very well, oxygen is 8. So there are 6 electrons outside. There are short of 2 to make 8. That's why oxygen always react as valence 2. Okay? You always try and bring 2 electrons into it. So H2O is perfect. Hydrogen got only 1 electron. Right? So the 1 electron will join one of this, and then another hydrogen will join. So they get 8. Very interesting, nicely fit. So that's why H2O is so common everywhere.
Simply.
Okay? So that's why I wanted to understand atomic physics, because this is very important to understand the world basically. A lot of phenomena. You know what's the periodic table, right?
Yes.
What is it for? To learn for exam. This is exactly what the teacher did. Okay? Actually, I'm surprised the teacher never emphasized the importance of periodic table. But all the chemistry are built into that periodic table. And because of this, yeah, because the periodic table is actually, interesting, this was independently discovered, but this fit into the periodic table very well. And all the chemical reactions depend on understanding of this. Okay? So don't have to go and memorize the equation of this. If you understand the periodic table, you'll know which chemical is going to react with which. Okay? Okay, so this is what it is. So it's a positive ion. When you lose 1 electron, it's called a positive ion. When you accept 1 extra electron, it's called a negative ion. Okay, simple, straightforward. Right. So these are the electrons, the different shells have different value of what? Energy. Right. So remember your photon is dependent on this shell. All photons are generated by electron jumping from one shell to the next shell. So if the shell has high energy, you come out blue light. If it's low energy, you come
No
out
lah.
red light.
Yeah, that's what I saw.
Or sulfur
The water.
infrared.
Don't
Okay.
never see bubble.
So all
It's not
electromagnetic
there.
energy are generated that way.
Going
Okay.
down now lah. Not worth lah. 1%.
So H2O, okay, these are the shells.
Oh my god.
Okay. Krypton,
Nice ah. Army
bonding, okay. Sodium and chlorine two together bond, okay, and this is isotope,
See for them
okay.
together. Kali they discussing no.
Okay, so they share one electron.
One.
Now this energy level, of course I won't ask you question, but it's very interesting to know how the energy level affects the electron behavior, okay? Right. So energy as you go up, now this is negative one, lower energy level, right, it goes up. Okay.
Silicon wafer. Wafer.
Okay, so if an electron accepts a proton, a photon, you will go up into one more shell, higher energy, okay? So every time a photon hit the electron, you move one more shell, okay? This is how, if this one fall back, you will release a photon, okay?
To prevent IP.
Then it goes back, okay?
Insulation or something.
As you go back, you release the photon.
Prevent copy.
That's how all electric
Prevent IP. Insertion property.
electromagnetic energy are generated this way. Electrons jumping back and forth. Okay? So we take a copper atom, right? Of course, I don't ask you a question on the deal. This is just to let you know that these are very powerful, what I call theories like this. Right? So copper has a lot of electrons free at that level, and that's why it becomes a conductor. Okay, right? And I put two copper atoms together, right? Close proximity, they share the energy band. Okay, right? So they share the energy band. The electron can move freely out here. Okay, you put many atoms together, this is what happens. Okay. So this is another measurement of that. Okay. So we put all these things for it, but I won't ask you exam question on this kind of thing, but it's good to understand it, okay? So conductor, semiconductor, we mentioned already, okay? Right. So conductor will have a lot of spare electrons up there, okay? Aluminium, okay? Insulator, they got big forbidden gap, the energy couldn't get through, so that's why it's called insulator, okay? Right. So now you come to this, when you rub this one, you get friction. What do you get? Okay, like plus, minus, okay? Right. So plus, minus, attract, minus, repels, say forward line is a screw. Okay, important thing is that you have to recognize all this. Right? What is the meaning of protective, susceptibility, and grounding? And this is what you see on the aircraft. Okay? Right. ESD, this is important because we realize that the transfer electric between body, these are the what I call susceptibility. Okay. Now what is SCR?
Silicon control rectifier.
It's a thyristor, okay? Silicon control rectifier.
What's the difference between SCI and thyristor?
Yeah, prof. What's the difference between SCR and thyristor?
Same.
Huh?
It's the same thing. It's a different name. That's all.
But it's the same thing. Sure, confirm? Confirm it's the same thing?
You got it, huh?
He wants you to bet money.
Correct.
In the early days, we call
Oh, but give you too
SCR.
much.
But later, they I don't know how the word thyristor
Some
comes.
prof chose to.
Okay, so I think one of them could be a broader. No? I think SCR is more narrow. Thyristor got a few variations.
Ah, he got different really.
Not the different. The SCR is a thyristor, but thyristor got a few other variations. Because SCR was the first one to control rectifier. Later they create other things. I'm not sure. You can check out. All this is my knowledge 40 years ago. Pardon me, I can't remember.
It's okay lah.
Okay.
2 marks.
So BJT
Go to you, please.
bipolar junction transistor. Your normal transistor is called a BJT. Your standard transistor is called a BJT. Okay. Okay. So this is your base. This is your collector. This is your emitter. Okay. Okay. So this is called a BJT because it has two junctions. It's called bipolar junction transistor. Now these are quite resilient, so it's not a problem. Okay. It's not a problem. Okay. Later the earliest was the CMOS. MOS stands for metal oxide silicon. Okay? This is very important. Metal oxide use very little current. Okay? And because of that, they are very susceptible to a lot of damages happen during the early days. Then this is the thin film resistor, of course, it's more subtle. More important revolution is this. Today, a lot of your memory chips, everything are using MOSFET. Okay? FET stands for?
Field emit.
FET, fuel.
Field effect transistor.
Field effect transistor. Field effect transistor.
Why you mind fuck me?
Who you meant, Jimmy?
Here we have this one controlling the current below voltage, okay? BJT, okay? A field effect transistor has no conduction. It actually has a field that regulates. So you see the silicon like that, right? This one has a junction. But field effect has no junction. Okay? It is just a field effect. Okay, so you put the power here, it affects the field here. Okay? So it's very interesting. It has no direct junction, but the field effect regulates here the junction regulates the electron. Here, this one regulates. There's no physical junction. That's why, and it became very, very useful, and of course, very susceptible. Okay. Right. So this is EROM. What's the EROM? Ask you now, expert.
I don't know.
Expert.
I know a
5-pointer.
programmable ROM.
Okay, you got it right. Programmable ROM. Okay, what's
I don't know.
EA?
Electrically.
Electrically, okay.
First one correct. What's the second one? What?
Adjustable.
Kind of.
Electrically alterable.
Oh.
Okay.
Same.
Electrically alter the program. Okay. And what is this? Thumb drive. Your thumb drive is a euro.
Your thumb drive.
See, you're right in front of you. Thumb drive is your euro. Okay. And this is very susceptible. Don't forget that. Why? Because the thumb drive is very efficient. You use very little current. Okay. And because you're using low voltage and low current, it becomes more susceptible to damage. Okay. Of course, this is even worse. Okay. So this is the range of things that sensitivity to. So that means you handle them with different. When you buy a transistor, right, you just take home and solder, no problem. Right. If you go and buy a FET or EROM, or not EROM is assembly, but FET, they'll come in with a black foam. So you gotta put it there before you take home. If you don't, by the time reach home, you gone because your finger, all this, it could cause you to zap it. And I lost a lot of things. Those days you don't pay attention. Right. You work everything, it didn't work. Then you realize that it was zapped. You see? Yeah. Okay, so these are the things that we went through. These are the early failures I mentioned to you, altered response pattern. Okay, this is important. You need to know the basic principle of static control. Okay. So the question may be asked: design immunity. That means when you design, like for example, if you use a FET, then you have to be very careful with your electrostatic thing. Okay. But if you design BJT, then you have to pay attention. So depending on what you're using, okay, you don't have to overdo it. Okay, right? So design immunity very important. You have to understand and protect it. Eliminate and reduce generation. What is the mechanism to do this? Eliminate and reduce generation. What's the mechanism? Does your wrist strap does that? No, the wrist strap does not eliminate generation. The wrist strap is to ground it after it has been generated. Okay. So to design immunity, you got to understand the tribal chart.
Static back
Okay.
or conductive?
So eliminate means that, for example, your bench, working bench today, they're all conductive surface. Okay, this is to reduce and eliminate, prevent it from generating at all. Okay. Dissipate and neutralize. Your wrist strap is to dissipate and neutralize. That means you don't know where is it generated, then you wear this strap to kill it off. Okay. Then of course protection. You need all those end caps and everything, protective covering. So you got to understand this concept. Okay. So these are the controlling, right? So this, you understand which one belongs to which principle, okay? Okay, if you go to aircraft, you'll see all these what we call caution, like this is a standard aircraft decal, okay? Then your wrist strap is to ground, it's not to prevent generation. And somebody was trying to sell wireless wrist strap. Actually, fake news, there's no such thing, okay? Doesn't mean a standard, okay? Okay, how you test, okay? Right, and these are the end caps. If you go to aircraft, they always have this LRU, and behind you see all the pins, okay? And you have to put one of these caps. In the past, you were always black. Nowadays, got different color. But they carbonized in the early days. Okay, so this is important. Dust cap, we call it dust cover. Right. So you never carry an LRU and carry it around. You make sure that it has an end cap. So this is what the process of ESD protection. Okay. If you're handling printed circuit, you have to put into a proper protection, what you call a special protective plastic bag. Okay. Right. So you notice that all the electronic card will come with this. Okay. Okay, these are savior rules from the manufacturer to device manufacturer. So when you buy a chip, they always come up with a foam, a black foam, right? Like this one will always come up with a bag, special bag, conductive bag, and your workshop, the badges are supposed to be conductive as well as grounded. Okay. So this is how the ESB bag looks like, have protective containers and all that. Okay, any question? So ESD, there will be a few questions, of course. I don't think there are many. Okay. So the kind of question I'll ask you is more operational. Okay, I won't ask you a lot of the theory. So let's look at the electromagnetic. Yes.
Silicon oxide package. Maybe silicon oxide package.
Okay, SMC. I went through some of the questions and I just try and recall some of the questions that you asked.
Wait, SOP.
Not many people ask this ESD and SMC.
SOP.
Many of you asked navigation computer questions.
Small outline.
Surprisingly, just only done this morning. Okay, so the important thing about what you call certifying the software is like whether the software can lead to catastrophic accident. That means it's a failure of the software, it can crash an aircraft. That's important. Okay? Right. Whether it has a hardware-induced threat, right? That means whether your hardware can actually cause the system to fail, or software-related. Hardware-related like your ESD. These are hardware-related threat, induced threat. Okay. EMI is also considered hardware. Software is actually the program itself. Okay. That means the programmer make a mistake or something like that. So these are the kind of failures. Okay. So because you're using fly-by-wire, right, we have a lot of ways to make sure that this thing don't happen. And one of the ways we do is to have fault-tolerant hardware and fault-tolerant software. One of the most important thing about hardware, you know about it, right? What's important thing about software is that your chip, you don't happily use your computer like you use Apple, you use what you call Intel and all these things, happily use them, right? Now, if one of the programmer in Intel programs something wrong, okay, it can affect a lot of computers, right? So in the aircraft system, you see you have this elect and this spoiler for this thing, all this hardware, 5 channels of autopilot. Okay. The 2 channel cannot use the same chip. See? Because if Intel program an error there, the same programmer, it affects both channels. Then your effort to have duplication is wrong. So we take care of all these things. Not only that, the people who design must not be the same company. Okay? different companies and different teams as well within the company. So it's very important. These are all the things that we take care when we do fly-by-wire. It's very critical. Right? So software development in fly-by-wire becomes very, very important. We take care of everything. So this is the system that I will talk about tomorrow or next week. So they have this simple thing like the control channel is permanently monitored by a second channel. So every autopilot has two channels, one always monitoring the performance of one channel. So every autopilot system has this. And if there's a disagreement, okay, the computer affected by the pillar must not interfere with operation of the second one. What you call this? This is what we call fail passive system. Okay? So systems are designed with fail passive. What is fail safe? Fail safe is standardized, everything has designed fail safe. What's the meaning of fail safe? How do you define it?
Redundancies, backup.
Huh?
Redundancy.
No, fail safe is not just redundancy. It has to fail in a safe condition.
Oh.
Okay, right.
Cannot
So that's the reason why electronics or electronics are so
catastrophic.
expensive, because
Catastrophic.
they have to prove to the regulator that they will say, okay, if I cut this wire, what is going to happen? When a failure, the system must be safe. So as I mentioned, the simple thing, like if I ask you to do electrical door, I say I want it to be fail safe. If there's a power failure, what happens? The door open or close?
Close.
Close and the date inside.
Make it open.
Right? Yes,
So
we
it's,
open, right? That's the simple meaning of fail safe. That means if something wrong, the thing has to be open so that you can run out. Okay. But if I ask you to design a bank vault with the same electrical system, what's your fail safe mode?
Auto lock.
Close. You have to close because you're going to protect all the money, Okay? So you can see each situation we have to go through this cycle of asking questions. Now on your car, anybody who drive a car here, I'm very worried when I drive a car, you know why? Your brake is not fail safe. That means you won't know you fail until you want to brake. Then you realize, wow, your brake is not fail safe. That is the problem with the car. So be careful, okay? Because you won't know they fail until you want to brake. Whereas
That's why
on the bus, the
The
pneumatic brakes is actually fail safe.
Split second
The bus
decision
use
all it
pneumatic
takes.
brake. They use the pneumatic pressure to lift the pad off. So when the pneumatic fail, it's always locked. The brake is on all the time. So they use the air pressure to lift the brake, to move the bus. Okay? So that is fail safe. This is a simple illustration of what you achieve. Okay? So all aircraft systems have to go through fail safe design. Okay? Now further, if you have multiple channels, you have to do fail passive. That means the fail channel should not interfere the working channel. Okay? I give you an example of how a fail passive system fails. You know the A310, no sorry, not the A310, the BAC-111 aircraft, where the pilot got sucked out of the cabin, remember? The windows, they use a lock screw, okay? Now what happened is that when the pilot was sucked out of the window, what was he doing? His whole body was pushing the control column down.
Oh shit.
Okay? So the guy, when he got problem, is causing the other pilot to fight against it.
The whole engine blows up, bro.
Yeah.
support.
So the guy got problem trying to control the aircraft, the co-pilot. Because the pilot was leaning onto the control column. So that is not fail passive. That means this guy failed and it is interfering with the co-pilot. Bad design. That's why now the aircraft don't have that, right? You only have joystick one. I think they learn from there. Okay.
Yeah, right, you can learn from
So
that.
that's what I mean by fail passive. Okay. If you fail, it must not interfere with the other operations. Okay.
It must not interfere.
Now, of course, in autopilot, next week I'll talk to you, like you need to have full operation and then fail tolerance system. Today, a lot of aircraft are built with fail tolerant. Okay, so this is the gap to this is what happened, and okay, this is just the flight control which we'll discuss next week. Okay. Now the other thing is the RTCA. What is RTCA? Radio Technical Commission of America. Okay, it's a advisory thing that determines the software certification. Okay, FAA recognized DO-178 as a guideline for software development. So DO-178 specify there are 5, the DAL, right, because the design allowable level, catastrophic, hazardous, major, minor, no effect. So they define all these things. So DI is, we use our CCAS to define all the definition A to E, okay? And this is what it meant. A is catastrophic loss. That means a failure of an A can cause an air crash, okay? Hazardous, if the crew cannot perform, that means it's a serious disability of the aircraft. Okay. Major workload is impact, okay, there will be discomfort. Then the requirement is remote, extremely remote, extremely unlikely, and this is a probability of it happening, okay? So this one E is no impact, okay? So what happened in the 737 MAX?
The thing no start.
They design
Single point failure.
a single point failure, okay? Right. So what is why you're not allowed to have a single point failure if your software is classified as catastrophic at A or B. You cannot have a single point failure. Okay. So Boeing violated this rule by putting the flight control, most of flight control are classified as A. Right. Now, landing gear and all these are normally classified as B. Okay. And most other, like no other that has duplicate system, like some navigation system, normally they are between B and C. Okay? So different system will be classified differently. This is how the software system works. Okay? So Boeing, somebody cheated the system and classified the MCAS system under C. That's why they designed a single point failure. That means only one of the AOA, angle of attack, sensor will feed in the information to the MCAS computer. So when that AOA failed, it gives the wrong information to the MCAS. Okay? And that's why the aircraft crashed. Okay? So on investigation, they found that somebody violated by training because it's supposed to have 2. Because the flight control system is supposed to be under hazardous. But there's a very long story I can tell you one day why the boy did that. Up to today, because for commercial reasons they did that. If they put 2, you see what the problem is that if you put 2 pieces of information, if they disagree, what do? You don't know who is right and who is wrong. You see? So the whole operation system has to change. And if you do that, you have to train the pilot. And Boeing is trying to avoid pilot training in selling the 737 MAX. Okay. So the lawsuit is not over yet. Actually, it's a very serious part. Okay, so this is how we classify them. Okay, the other part is software management. Now all the computer has got software. Some are loadable software, some are short loadable software, you know. And because of that, you see, it becomes a very complex process. Okay. So they have to certify the software differently. So if you have a program, who is the one who can actually load a new program onto the aircraft? It's the LAE. He's authorized to do that. Okay. But some of the program, that means if it's a software, the online loadable, right? The software carries a part number, separate part number from a hardware. But if the software is this called LRU, if the software is what I call control by, let me see what is it. They call it a shop loadable software. If the software is loadable in the workshop, that means nobody can tamper with it. The LAE cannot change it. Then the software do not carry a separate part number. The software part number is incorporated into the LRU revision number. Okay, like revision 5 or something like that. They have a different part number. But if it's loadable, then they have a separate part. So a very simple control system. Okay. Right. See, this is how the improvement of using loadable software. Okay? In the past, some of the system is 40 hardware. Today, they only one part number. And different software let them to do different operations. So you look at the 787-350. Amazing. Now they even don't have a lot of LRU for each job. They have cards, different cards to do different jobs. And they're all programmable. Okay? So this is actually tremendous saving of what? Wait. First of all, hardware, weight, part number control. There's only one hardware, the rest are all software. See? So for the airline, it's a tremendous advantage. Okay. So we mentioned to you onboard software loadable system. Okay. Right. Now this is the early days. Loadable software started in the early 747, 747-400 called Access. Okay. Actually, it's a nightmare. Because the cabin got so many configurations, you know, the lighting system, your in-flight services system. Oh, I was in charge of that. And Boeing suddenly found that there are about 20 software that we need to track. So each aircraft has for what, and they don't have a system. So I had to design a whole system to control the software because we are the one earliest by the 747-400. Okay. And it was quite interesting, but today I look back and say, I don't know how they allowed me to do that. Because there's no computer in those days. I was using my personal computer to duplicate the flight data to be distributed to the aircraft. Of course, I know a bit of this, I do some control. But it's actually, looking back, it's actually a very dangerous thing. But I was always trying to remember this thing. Okay, somebody, Ediru, all these things are the systems. Okay, so the procedure here is loadable software. That means when you buy them, there's a process to check it before you can put on the aircraft. Somebody got to certify it. Okay? Like you manage the libraries, right? Like preload software, do loadable LRU, that's very important. Okay? Sometimes you preload out of that. That means you don't let the LRU do it. You put in a shop, then put the whole LRU inside the store. That means you got to buy more LRU. That's not a good idea. So if a large fleet, it can be very significant. Okay? Okay, verify conformity again. Okay. So loadable software, there are a few types. One is called operational software. One is called like operational program configuration, just a configuration. Database, the nav database, your flight management computer has the nav database that needs to be updated every 28 days. So every 28 days you got to go and put the disk inside there and change it. Okay. Now there's this thing called AMI. This is the airline. The airline has their own system, okay, independent of the manufacturer. Okay. Okay, so this is OPC. They call the operating system of LRU, right? Contain operation program. See, every like your system, like you have your Windows is an operating system, right? But your Word and all these things are the operational program. Okay. You need both of them to be certified separately. Okay. Okay, AMI, these are the airline operator small data file. Okay. Managing library, right? Important that you have to, somebody has to control it. Okay. So I mentioned to you this one is repeat. But interestingly, good thing is that when you load a software, the LRU will tell you the software status. This is the display. You can actually read the software status. Okay. The aircraft have this system to do that. Okay. These are all the processors. Okay. So today, revised software is programmed into EEPROM. Okay. Of course, we use EEPROM nowadays. Okay. And it's issued as a unique part number. That means if a program can be updated when the aircraft is online, right, you need to have a separate number. Okay. Okay, that's all. Any other questions? Your, what we call your project? No questions? All done already? So your presentation is on week what?
12.
Week 12, right? Okay. I will try and issue the, so next week is the last lecture week. So your presentation will be there. I'll give you the timetable. Okay? And your test will be week 13. Okay? Yeah, I have a problem because next week I'm going to give you the aircraft system 2. So we don't have much time to talk about aircraft system 1 and 2. So we have to think of a way to get around because after the presentation last time. Okay, so you got questions, you better ask quickly. I think next week, I will try and finish off all the revision. Okay.
Untuk 7-8 topics. I think you have it. I think you go through video.
Yeah. Yeah, send my email. You can use, you can send me to this email. Okay, we got question, you can send me. Don't send to the SIP because I don't want to access the SIP system. Just now I'm trying to access this. They won't even let me say no internet connection. So here's because I come here once a week, so they don't give me a lot of access. Alright. So you send to my NTU email. Yeah. So any question?
Lecture recording.
So this pen.
What Prof,
Yes.
Prof, the lecture recording you uploaded already.
On already what?
All up already.
How many days? You have got it? This morning I did it.
Check.
What?
Oh, check. Check.
Last time I did it.
Never check.
No, last time I
Kang never check.
You check right? Up already. Yeah.
Not bad, no? I bet $10. Upload already.
Cause he say already you keep quiet.
Tada.
Wait, already oh.
See? Come, pay up.
Oh, they right?
Wait, must see, must go in first.
What I see?
This guy don't believe me. Huh? Now you must pay up $10.
Wow, $10 only.
Eric is not comfortable.
I must understand his situation. He's trying to save money. You want to buy Tesla Model X?
Wow, that's good. What's so good?
I'm not buying a Tesla. Tesla is very bad.
Tesla is bad, why?
Because
You don't like
it's
Elon
not as
Musk.
high tech and good quality compared to other cars.
There are better cars around,
Yes.
but it won't be so cheap.
You want to buy Bugatti, shut up.
Cebu, that's Wi-Fi.
No, it's fun. Actually driving a car is actually very interesting. One day my son asked me, we were trying to buy a car. And he asked me a question I never forget. He said, Papa, are you buying a car or buying an appliance? Because we are talking of maintenance costs, we are talking of cost of operation and all these things. And he said, are you buying a car or buying a... Then I said, what's the difference? He said, appliance is when you don't like the car, but you have to drive it to go somewhere. That's an appliance. Okay. A car is you love the car. You just drive it, you don't care where you go.
Hello, that's why Eric.
I mean, I learned from my kids a lot because I was shocked by we old people always look at maintenance costs and all these things. But I never look at my daughter and my son, they plan, I don't know how they tricked me to buying a sub car. I used to buy Japanese car. So I end up buying a sub. They actually very interesting. They talk to the salesman and then they were teenagers and then I went up, end up the shop and buy the car. Okay. And I learned exactly what he said is true. When I drive a sub, it's a different experience from driving a Mitsubishi or, and I could drive very, as an executive airline, the time is important. So every time I get into a car, I don't have to worry about everything. You see? And I find that has value in me. So that's why I learned from my children that actually a car is different from, and I love driving that car.
So what car is driving now?
Now I don't know. Now all the cars sold already. I drive car that nearly finished. This car going to scrap in 2 months' time. You know, I'm retired already. I'm not airline executive. Last time airline executive, I need to think. Now I don't need to think. I just come and
He
talk.
aspired to be like you. Yeah.
You also
That's power there.
You want to start business together, MRO company.
Yeah.
We
I can give free advice. You can't see me.
learn from many people.
I work in MRO all my life.
Stop following your passion.
Yes.
No, you have to follow your passion. That's
So you need to make a video.
No, it's
Got this
true.
guy, this guy in the YouTube ad, he always say, stop pursuing your passion.
Why?
I skip after that.
He said,
I don't believe the crap.
You must pursue your passion.
Prof, I record you, you say that.
No, you can see me. What you go to YouTube? I spoke about this.
Huh? Really? Ah?
You go to YouTube. You go put my name, yeah.
Search his name.
YEOW.
Just put my name, Lim Yao Ki is there.
Suggestion.
Yeah, YouTube.
Oh, play there.
Many years ago, they
So he's still president.
I'm still president.
Very long.
Feels long ago, about 5 years.
Same lah. Teaching students and talking.
Okay, there's no question. You all got no question. You all can leave and go and study if you want, or you can sit here and you can ask me more questions. I don't know. Yes. Actually, a lot of these chemical technologies are trying. The 155 nothing is just new.
Yeah, so here we are.